हेलो एंड वेलकम अगेन। सो ऑप्टिक्स के रिलेटेड जो क्वेश्चंस आए थे टीएफआर में वो हम डिस्कस कर लेंगे। ओके, बेसिकली दो ही क्वेश्चंस आए थे तो वो हम अभी डिस्कस कर लेंगे। फर्स्ट क्वेश्चन इज लेजर लाइट इज इंसिडेंट नॉर्मली ऑन अ थिन फिल्म ऑफ मटेरियल विद a direct index ns larger than that of air, na equals to 1. As the wavelength of the laser light is varied, the intensity of the transmitted light through the film shows a peak at 633 nanometer. If the thickness of the film is 118 nanometer, the minimum ns is closest to. ओके, सो ये हमारे पास चार ऑप्शन है। सो बेसिकली क्वेश्चन ये है कि हमारे पास एक थिन फिल्म है। सपोज दिस इज माय थिन फिल्म। सो दिस इज माय थिन फिल्म ऑफ डिस्टेंस ऑफ थिकनेस। सो थिकनेस जो है इसकी, सो दिस थिकनेस इज डी इक्वल्स टू 118 नैनोमीटर। ओके, और एक लाइट पास की जा रही है, एक लाइट पास की जा रही है। सो दिस इज माय लाइट। ओके, सो दिस इज लाइट ऑफ वेरिड वेवलेंथ। ओके, एंड यहाँ से कलेक्ट की जा रही है। ओके, then it's observed that if we plot I versus lambda graph, intensity versus lambda, so this is I versus lambda, then it's observed that at around lambda naught एक peak आ रहा है। So lambda naught equals to 633 nanometer, एक peak आ रहा है lambda naught पे, and lambda naught equals to 633 nanometer। तो हमको ये बताना है कि किस NS refractive index of this film कितना होना चाहिए so that 633 नैनोमीटर का पीक मिले ट्रांसमिटेंस में। ओके, सो बेसिकली क्या हो रहा है कि ये लाइट पास हो रही है। ओके, बट एट द सेम टाइम लेट मी जूम इट। एट द सेम टाइम क्या हो रहा है, ये लाइट रिफ्लेक्ट हो रही है, ये लाइट रिफ्लेक्ट हो रही है यहाँ से रिफ्लेक्ट हो रही है, देन अगेन यहाँ से रिफ्लेक्ट हो रही है, फिर जा रही है वापस। सो दैट मीन्स देयर मस्ट happening some kind of constructive interference. Okay, so only when constructive interference happens then the intensity will get maximized. Okay, so that means this line and this light must have a phase shift of 2 pi or any integral multiple of 2 pi, so integral 2 n pi. So in terms of wavelengths, this should be equals to m times lambda. Okay, so this distance, the extra distance that light travels, so this extra distance this light travels should equals to m lambda. Okay, so that means 2d should be equals to m lambda, but we're talking about the optical distance, so we have to multiply by n. So 2nd equals to m lambda, but the question says the closest, so let's take m equals to 1, m equals to 1, so 2nd equals to lambda, so n यहाँ से हम निकाल सकते हैं equals to ns, more specific, lambda by 2d. Lambda we know is 633 divided by 2 times d is 118 nanometer, so it will come around 633 divided by 2 into 118, so that will come around 2.68. Okay, so that means option number A. The next question is, a stream of electrons, each having an energy 0.5 electron volts, impinges on a pair of extremely thin slits separated by 10 micrometers. The distance between the adjacent minima on a screen 20 meters behind the slits would be closest to. So हमारे पास slits given है. So suppose this is our slits, okay, and this is our screen. And electrons shoot किए जा रहे हैं. Suppose this is the electrons that are being shooted. Okay, so these are our electrons. Okay, and when they reach to this slit, so this is slits. Okay, let me highlight it. So this is our slit. Then what happens, they come right from this one and this one, and at this screen, so this is our screen, they interfere because we know electrons behaves as waves, so we'll get some kind of a pattern, and that pattern would be like this. So let me draw it here. So we'll have maxima, then minima, then again maxima, then minima, and so on and so forth. Okay, similarly in this side also minima. By minima I mean dark fringes where destructive interference occurs. Okay, so this is the middle one, central bright fringe, wide, and the D is given as 20 meters. Okay, 20 meters. Now we know the first what we have to find is the distance between the adjacent minima. Okay, so suppose this is the first minima and the second minima. Let's find the distance between these two minimas. Okay, so we know, suppose this is the location for the first minima and this is the location for the second minima. Okay, now we know for minimas a sine theta, the first minima. So for this, it should completely destructive interference should occur. So a sin theta should be equals to lambda by 2. For the second case, a sin theta should be equal to 3 lambda by 2, right? Now, so this is the theta here. Now for small angles, sin theta is approximately equal to tan theta, and which we can write as y1 first minima divided by d, or simply y divided by d. Okay, y divided by d, y divided by d. Okay, so for the first case, first minima and second minima, I can write a tan theta, so that is y1 by d equals to lambda by 2, and for second I can write a y2 by d equals to lambda 3 lambda by 2. So this is y1 and this is y2. Now the separation between them, so I can write y2 minus y1 will be equals to 3 lambda by 2 minus lambda by 2 multiplied by d by a. So that means the separation between adjacent minimum will be delta y, which will be equals to lambda d by a. Okay, so this is the distance between the minimas. Okay, consecutive minimas. But what about the lambda? So lambda for electrons we know is given by the Broglie wave equation, h by p, where h is a Planck's constant and p is the momenta, which we can write it as 2m e, where m is the mass of electron and e is the energy of the electrons, kinetic energy. And e here is given as zero point 0.5 electron volts, 0.5 electron volts. Okay, which equals to 0.5 into 10, 1.6 into 10 to the power minus 19 joules. And h we also know, so if we can compute this lambda, so lambda equals to 6.6 into 10 to the power minus 34 joules second divided by under root of 2 into mass of electron we know is 9.1 into 10 to the power minus 31 kg times electron, this energy, that is 0.5 into 1.6 into 10 to the power minus 19 joules. So if we compute it all, we'll get lambda as equals to 1.74 into 10 to the power minus 10 meters. So this is lambda. Now we know what lambda is, so we can compute delta y. So delta y equals to 1.74 into 10 to the power minus 10 times d. D is your 20 meters. 20 meters divided by a is the slit separation. So a is your slit separation, which equals to 10 micrometers. 10 micrometers minus 6. Okay, and yeah, so if we can compute it all, so let me try to compute it. um so the value becomes 3.48 3.48 nanometers, sorry, millimeters.